morning, all of you. This is our science class in class 10. We have to start chapter number 4, carbon and its compounds. So, this chapter, carbon and its compound, belong the branch of chemistry known as organic chemistry. In our earlier lecture, we have discussed some chapters of inorganic chemistry like metal and non-metal and some chemical reactions. And now our chapter number 4, carbon and its compound, belong to the another branch of chemistry is known as organic chemistry. So, first of all, we can say that what is organic chemistry? The word organic comes from the organ. You know that our body consists of many organ to form organ system, and many organ system produce our body. So the word organic comes from organ. It means the branch of chemistry deals with those carbon and its compound which are responsible for our life or from which we can produce our life-saving drug are known as organic chemistry. So in organic chemistry, we have to study those organic compounds which are essential for our life and living process. So we can discuss carbon and its compound. So you know the carbon is an element. Its atomic number is 6 and mass number is 12. So we have to represent carbon 6C12. Where 6 is its atomic number and 12 is its mass number. You know that atomic number and mass number will be there. Atomic number is equal to number of electron is equal to number of proton. So its atomic number is 6, then we can say that atomic number of carbon is 6. So we have 6 number of electron and 6 number of proton. So in carbon, number of electron is 6, number of proton is also 6. Electron has negative charge particle and proton is a positive charge particle. Now, this is the mass number of carbon. Mass number is equal to number of proton plus number of neutron. So the number of proton and number of neutron also combined to called nucleon. Nucleon means number of proton and number of neutron. So sum of the number of proton and number of neutron is known as mass number. So we have to calculate number of neutron. You know that its mass number is 12. Its mass number is 12. Number of proton is 6. Then we find number of neutron. So plus 6 here transfer into the minus sign. Then number of neutron n is equal to 12 minus 6 is equal to 6. So number of neutron in carbon atom is also 6, and it is neutral species means neutron has no charge. So this is the carbon. You know carbon is a unique element. Why do carbon called a unique element? So carbon is called a unique element due to the following reason. First one is that its configuration is 2 and 4. To retain the most stable configuration of its nearest gas is helium, or next one is neon. So if it remove these 4 electrons, carbon remove these 4 electrons in its outermost shell, then it retains the configuration of C4 plus ion. It means that it removes its 4 electrons and it forms carbocation. Cation means it has positive charge and it retains the configuration just like a helium. Just like a helium. This is the nearest third case. When carbon accepts 4 electrons, carbon accepts 4 electrons to complete their octet, then its configuration becomes 2 and 8. It accepts 4 electrons, then its configuration becomes 2 and 8, which is nearest inert gas neon. So in this case, carbon requires 4 negative ion. It means it forms anion. So carbon forms 4 cation as well as anion. That's why it is known as unique element. The second reason, this is the first reason. The second reason for carbon knowing as a unique element is that because it has the property of catenation. You know what is catenation? Catenation means it forms long chain compound. So carbon forms long chain compound like that. Due to its valence C4, it forms long carbon chain compound. This property of carbon is known as catenation. That's why it has enormous number of compound. It has enormous number of compound. So due to this property, carbon known as a unique element. Do you understand? Okay. Now our next topic of this chapter, bonding in carbon. Bonding in carbon. So our next topic of this chapter is bonding in carbon. Bonding in carbon, it means carbon, how does bond, formation of bond and form new compound with other element. So the bonding in carbon mostly covalent. What is covalent? The bonding of carbon mostly covalent. What is covalent bonding? Covalent bonding means when these 4 electrons of carbon, there are 4 electrons of carbon in its outermost shell. when these four electrons form bond by the equal sharing of electrons, by the equal sharing of electrons, then such type of bond form is known as covalent bond. When four electrons of carbon, due to the equal sharing of electron with another atom and form a bond, is known as covalent bond. For example, here carbon, its valency is 4, so there are 4 electrons, 1, 2, 3, 4. These 4 electrons present in its outermost shell, and these 4 electrons combine the 4 other electrons of another atom to form a bond by the equal sharing of electrons. So such type of bond is known as covalent bond, and compound is formed due to this bond is known as covalent compound. Example, methane. This is the example of methane, Ch-4. It is the simplest organic compound. So this is the bonding in carbon is covalent bonding. Now next topic is melting point and boiling point of some compounds of carbon. Melting point and boiling point. Melting point is the temperature when a substance is melting. This point or this temperature is known as melting point. And boiling point is the temperature where the substance is boiling up. So this temperature is known as its boiling point. So boiling point and melting point of carbon compound have low melting and boiling as compared to the ionic compound. This compound is covalent compound, and what are ionic compound? So ionic compound are the compound which form by the formation of ionic bond, and ionic bond formed by the exception or donation of electron. Like this is the example of ionic compound. Sodium has a positive charge and chlorine has negative charge. So these opposite charge bounded together by electrostatic force or ionic force. So this type of bond formed between the two opposite ions is known as ionic bond. So melting point and boiling point of ionic compound is more than that of the covalent compound. So the melting and boiling point of carbon compound is less than as compared to the ionic compound. Now conductivity. The ionic compound are more conductor or shows conducting property. It can dissociate from conduct electricity, or in its molten state they conduct electricity, but in covalent compound it is bad conductor or insulator, so it does not conduct electricity. Now next topic is carbon shows formation of long chain compound, and this property of carbon is known as catenation. We have discussed this property previously. Now we can see that the formation of molecule of hydrogen, single bond, double bond and triple bond. Now we have discussed the covalent bond, single covalent bond, double covalent bond and triple covalent bond. So our next topic is types of covalent bonds. Let's see types of covalent bond. You can see the first example of covalent bond in methane. In similar way, where this is the example of double covalent bond. You know that oxygen atomic number is 8 and its configuration is 2, 6. To retain the configuration of nearest inner gas neon, it takes 2 electrons. So in its outermost shell there are 6 electrons and it requires 2 electrons for complete their octet. Octet means 8 electrons in its outermost shell. So here another atom of oxygen which have also 6 electrons in their outermost shell. Both atom has 2 electrons, need 2 electrons to complete their octet, but it cannot give their 2 electrons, so both the atoms combine together by the equal sharing of electrons, because neither of atom give its 2 electrons for the bond formation, so they are combined together by the equal sharing of their 2 electrons. Now let's see, they form covalent bond by the equal sharing of these 2 electrons. So this type of bond is the example of double covalent bond. It formed by the equal sharing of 2 electrons. So in oxygen molecule, then oxygen molecule is formed, and in oxygen molecule there is double covalent bond. So in similar manner, we have to take the example of triple covalent bond. Let's see, nitrogen has atomic number 7. Its configuration is 2, 5. So there are 5 electrons in the outermost shell of nitrogen. There are 5 electrons. So there are 5 electrons in the outermost shell of nitrogen. So it has need to 3 electrons to complete their octet and its configuration to this nearest gas, inert gas. Then what can you do? Here it has 3 electrons, but it cannot give its 3 electrons to this nitrogen. Neither this of nitrogen gave 3 electrons to this nitrogen. So these 2 nitrogen becomes the equal sharing of electron. So these 3 electrons, due to the equal sharing of electron and form covalent bond. So this is the example of triple covalent bond. In similar way, carbon also shows single covalent bond, double covalent bond and triple covalent bond. Now we can see the example of carbon in single, double and triple covalent bond. Okay, let's see. Now we can see the example of single, double and triple covalent bond in carbon. First example, you know seen earlier. First one is methane. It is the example of single covalent bond. Second one is this is the ethene, and it is the example of double covalent bond. And third one is acetylene C2H2. This is the example of triple covalent bond. Now let's see the structure of these three compounds, which shows single covalent bond, double covalent bond, and triple covalent bond. Now first one is methane. You know that carbon has 4 electrons in its outermost shell, and to complete their octet it required 4 electrons, which gets from the 4 hydrogen and form 4 single covalent bond. So these 4 hydrogen, due to the equal sharing of electron, form 4 single covalent bond. So it is the example of single covalent bond in carbon. Now our next example is C2H4, ethene. These are the 2 carbon. Each carbon has 4 electrons in their outermost shell. These 4 electrons combine with other element to form covalent bond and complete their octet. In this manner, this is first covalent bond and this is second covalent bond. Similarly, in this carbon also, due to equal sharing of these 2 hydrogen, there are 2 single covalent bonds are formed. Now these 2 electrons form double bond from this carbon atom by the equal sharing of 2 electrons. Now both the carbon has complete their octet to retain the most stable configuration, like 1, 2, 3, 4, 5, 6, 7, 8. They have also 8 electrons. Now count 1, 2, 3, 4, 5, 6, 7, 8. So both carbon retain 8 electrons in their outermost shell and obtain a more stable configuration. So this is the example of double covalent bond in carbon compound. Now let's see the other example, which shows the triple covalent bond. These 2 carbon atoms, each carbon atom has 4 electrons in their outermost shell. This electron combined with hydrogen to form single covalent bond. Now these 3 electrons combine together with the other carbon atom to form covalent bond by the equal sharing of electron. So in this manner, both carbon has 8 electrons in their outermost shell. Count this 1, 2, 3, 4, 5, 6, 7, 8. In this carbon, they also have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So both the carbon contain 8 electrons in their outermost shell, and it becomes an example of triple covalent bond in carbon compound. So these are the examples of single covalent bond, double covalent bond, and triple covalent bond. Now we take the example of allotropes of carbon. The next topic of this chapter is the allotropes of carbon. So allotropes means the compound have same chemical property but difference in its physical properties are known as allotropes, and this phenomenon is known as allotropy. So there are three allotropes of carbon are there. First one is diamond, second one is graphite, and third one is Buckminster or fullerene. So these three are the example of allotropes of carbon. So the diamond and graphite shows different property and give different structures, but they have different physical property but similar in the chemical property. So the compound have same chemical property but difference in physical property are known as allotropes. So we have discussed three forms of allotropes of carbon. First one is diamond, second one is graphite, and third one is fullerene or Buckminster. So our first allotrope of carbon is diamond. Diamond is the hardest known substance. First one is diamond is the hardest known substance. It is used to cutting tools. Second one is the hybridization of diamond is sp3. Its structure is tetrahedral. So due to absence of free electron, it is big conductor of electricity. Now another thing is second allotrope of carbon is graphite. In graphite, carbon is sp2 hybridized. There is a free electron, so it is good conductor of electricity. Now graphite is slippery in nature because its hexagonal ring are slipped to one to another, so it is slippery in nature. That's why it is used as a lubricant. Now third one is Buckminster or fullerene. Its structure is just like a soccer ball or football. So it has 60 or up to more than 60 atoms combined in the form of a soccer ball or football. So it is known as fullerene. So these are the allotropes of carbon. Now this lecture is over here. We have discussed carbon and its compound. Now our next lecture we have to discuss different nature of carbon and saturated and unsaturated carbon compound. Now you read our next topic, the saturated and unsaturated carbon compound and different structure of carbon. So nature of carbon and saturated and unsaturated compound we have discussed in our next class. This class is over here. So take care of you. Goodbye. Thank you.